Hello everyone, welcome to the course on electrical and electronics engineering. In this session, we are going to see about AC circuits. We will discuss the basics of sine wave, its RMS value, average value, form factor and peak factor of sine wave, and also the rectified sine wave. So before knowing the basics, we should know how the sine wave is generated. So we are going, suppose there is a coil which has n number of turns, which is placed in a magnetic field uh, which has 5 webers. Okay, the coil is initially along this reference axis. In this position, along the reference axis, if the coil is there, the field will be perpendicular to the plane of the coil as shown here. Now we are going to rotate the coil in anti-clockwise direction. Just we are tilting from this reference axis. We are rotating in anti-clockwise direction with an angular velocity of omega radian per second. When the coil is along the reference axis at omega t equal to 0, that means theta equal to 0, it is called a zero EMF position. This is because the movement of coil at that instant omega t is equal to 0 is along the field. Okay, now at any instant t, the coil takes the position. Okay, at any instant, the coil can take the position like this. This is the plane of rotating coil, means it will take the position as shown here. At this instant, coil makes an angle theta. Okay, this instant it is making theta, that is equal to omega t with the reference axis. At this position, normal component of magnetic flux with respect to the plane of coil is normal component of magnetic flux is phi m cos theta, and we substitute theta equal to omega t means phi m cos omega t. Flux linkages, that is psi, at the at this instant y is equal to flux linkages is number of turns in the coil n into phi m cos omega t. According to the Faraday's law, the EMF induced in the coil, EMF induced at the instant under consideration, EMF induced, it's what? It is equal to negative sign of rate of change of flux. So that is the minus d psi by dt. That is equal to minus d by dt of n phi m cos omega t. If we take differential, minus n phi m differentiation of cos omega t is minus sine omega t into omega. So the term turns out to be positive, E equal to n phi m omega sine omega t. So we can calculate the EMF induced at various instants that we are going to see now. So at omega t equal to 0 or 180 degree, what happens if we put sine 0 or sine 180? We know that the EMF is total component will become 0. If it is 90 degree or 270 degree, what happens? So sine 90, sine 270, sine 90 is 1. Okay, sine 270 is going to be minus 1. So we are going to take this term n phi m omega as EM. That's the maximum value of induced EMF, right? The instantaneous EMF is going to be EM sine omega t and be plotted as shown here. Okay, the instantaneous EMF can be plotted as a sinusoidal wave. So we get a amplitude at different angles of rotating the coil. Okay, omega t is taken along the x-axis, and this is the alternating EMF for the complete cycle. Or we say complete cycle, one positive and negative instant turns out to be a complete cycle. Now we are going to understand some of the terms, okay, of the sine wave. First, what is a waveform? Waveform is nothing but a graph in which instantaneous value of any quantity is plotted against the time. So instantaneous voltage can be plotted against the time. Okay, this is one of the rectangular waveform. This is a sawtooth waveform, right? Alternating waveform, here, what do you mean by alternating? Here the wave changes direction at regular intervals. So at regular interval of time, the direction of wave get changes, as you can see the other continuity of this rectangular wave. Periodic waveform. Periodic waveform is the one which repeats itself at the definite time intervals. After this particular time, what happens? This is one complete cycle, right? Set of positive and negative cycle. It repeats actually. And here it's repeat. Okay. Sinusoidal and non-sinusoidal. If in the alternating waveform which obeys the sine law, it is called sinusoidal waveform. Non-sinusoidal also is alternating waveform where the sinusoidal law is not followed. Okay, here the sinusoidal law is not followed in these two waveforms, in rectangular and sawtooth, right? Now we are going to understand, we are going to take only the sinusoidal wave and analyze the AC circuits. So what do you mean by a cycle? As we said earlier, one complete set of positive and this is a negative half constitute a cycle. So if you could see period of one cycle. So this is a one cycle, right? Period is 0.5 second. So period is nothing but time period of the alternating quantity. The time period of the alternating quantity is time taken to complete the one cycle. Okay, it is going to be the reciprocal of frequency. Time period, as we know, is expressed in seconds. What do you mean by frequency? The number of cycles per second. Okay, that is known as frequency. Here, frequency is nothing but what is the frequency of this complete wave? It's 2 hertz. Okay, so number of cycles per second. Per second, how many cycles are there? You see, this is one cycle, this is another cycle. But 1 second, we have 2 cycles. So the unit is cycles per seconds or hertz. Now let us understand what is the amplitude. The maximum positive or the negative value of the alternating quantity is called amplitude, not this complete one. From the zero, either the positive value or the maximum negative value is going to be the amplitude. Now let us see about the phase. At any instant, we can find the phase of the wave. Here the phase of the wave is 0 at this point. Here it is 90 degree. Here it is what? 180 degree. Here it is 270. Here it is complete cycle 360 degree. Phase at any point is a time that has elapsed since the quantity has last passed through 0 point of reference. Okay, and passed positively. What do you mean by phase difference? If there are two sets of waves, here there are three they have shown. So this term is used to compare the phase of two alternating waveforms. As we can see here, EA it starts at 0 degree. So voltage A is a reference voltage. Okay, EM sine omega t. If it is lagging means this is the lagging wave EB. EM sine omega t, how much it is lagging by alpha angle. And here how much it is leading by beta. So EM sine omega t plus beta.
Now let us learn about RMS value, which is nothing but effective or root mean square value of an alternating current, which is defined by the steady state value of current, which when flowing in a given circuit for a given time produces the same heat as would be produced by the alternating current flowing in the same circuit for the same time. How much heat it is producing when a DC current is passed through the circuit in a given time, which will be the same heat will be produced by the AC current flowing in the same circuit for the same time. So to find the RMS value for sinusoidal current, we are going to assume IRMS, we are going to take this IRMS as root mean square. So root square root mean is 1 by the total time period square value. So we can't take the sum since it's alternating quantity. We take the integration 0 to t I square dt. We know that instantaneous value of current is Im sine omega t, where theta is nothing but omega t. So we can replace for I square as Im square sine square theta. So first we find the mean square value of AC current, then we will find the IRMS value. So since it's taken over the period, so 0 to 2 pi is a total complete cycle period. Im square sine square theta by t. So 1 by t is here, right? So 2 pi into d theta. Since Im square by 2 pi is a constant, we integrate the sine square. Before integrating, we apply the trigonometry. For sine square theta, it is 1 minus cos 2 theta by 2. Then we know the integration of a constant 1 is theta, cos 2 theta is sine 2 theta by 2. Already one 2 is there in the denominator, so it turns out to be 4. Then we apply the upper limit minus lower limit, we get im square into 2 pi divided by 2 pi into 2. Okay, because sine 2 pi and sine 0 is 0. Only for theta we apply the upper limit and lower limit, we get this. Cancelling out the similar terms, we get im square by 2. RMS value of alternating sinusoidal current is I is nothing but, what is IRMS? Root mean square. So root of the this mean square value. So we get Im by root 2. So it is nothing but 0.707 Im. Okay, similarly for sinusoidal voltage, we can write VRMS Vm by root 2 or 0.707 Vm. Now let us see about form factor and peak factor. What is form factor? Form factor is a ratio of root mean square value divided by average value of AC current or AC voltage. Whereas peak factor is given by peak value and its RMS value. Okay, the ratio of peak value and its RMS value. So we will find the first form factor and peak factor for pure sine wave. So we already found mathematically that RMS value of pure sine wave is nothing but Im by root 2, right? This one, Im by root 2, and its average value is 2 Im by pi. So if you substitute here and cancel the similar terms, we get Im get cancelled. Pi divided by 2 root 2 is nothing but 1.11. Whereas peak factor is nothing but ratio of peak value to the RMS value. Peak value is Im, RMS is Im by root 2, so we get root 2 as answer. Now let us find the RMS and average value for the rectified waves. First we will consider the half wave rectified sine wave. So this is the half wave rectified sine wave, where we get only out of this complete cycle over the period 2 pi, only half of the period gets rectified, right? 0 to pi, then 2 pi to 3 pi, like that. In that only we get instantaneous value of current. The rest it is 0 over this next period, right? Now we find the mean square value. Mean square value is, we consider one complete cycle. So mean is 1 by 2 pi over period. 1 by t is 1 by 2 pi. Integral of 0 to pi, we have the value Im sine theta, right? So I square we have to substitute mean square value. So Im square sine square theta plus pi to 2 pi is theta d theta. So in this region, the second region, the instantaneous value is 0. So we consider only this first integral. We take the constant out, Im square by 2 pi. Sine square theta can be written as 1 minus cos 2 theta by 2. So that 2 also goes out as a constant. Now integration of 1 is theta with respect to d theta, and integration of cos 2 theta is sine 2 theta by 2. Then apply the upper limit pi and lower limit 0. We know that sine pi 0, 2 pi, everything multiples of pi and 0 are 0. So we are left with only this pi alone. So that get cancelled. Im square by 4 is a mean square value. Taking the root mean square, we get Im by 2. This is for half wave rectified wave, right? Factor and peak factor for half wave rectified sine wave. For that, initially we have found the RMS value, then we will find the average value, then we substitute in this formula, right? So average value of the half wave rectified wave, since it's unsymmetrical wave, right? So average value is nothing but area under the curve for one complete cycle divided by period. So one complete cycle is 0 to pi, it has instantaneous value Im sine theta d theta, but from the integral pi to 2 pi, it is 0. So we neglect the second term. Integration of sine is minus cos. Then we apply the upper limit and lower limit. Cos pi, it is equal to minus 1. So already one negative sign is there. Minus of minus is plus. Cos 0 also it is 1. So we get 2 Im. That's the average. That's the area under one complete cycle. Divided by one period is 2 pi. So if we cancel, Im by pi is the average value for half wave rectified sine wave. So to find the form factor, which is the ratio of RMS divided by average, RMS is the one we previously found, Im by 2 divided by Im by pi, we get pi by 2, that is 1.57. Whereas peak factor is nothing but peak value by RMS value, Im divided by RMS is Im by 2. We substitute, we get 2 as the answer. Now let's see about RMS and average value of full wave rectified sine wave. This is a sinusoidal wave that we well known. Now the full wave rectified sine wave is nothing but for both the cycles positive and the negative cycle, it is getting rectified. It's nothing but full wave rectifier output, right? So to find the RMS, first we find the mean square value, which is nothing but area under one squared curve divided by period. But since each of the cycle is rectified, we take the total period as pi. So 1 by pi integral 0 to pi I square d theta. So I square is nothing but Im square sine square theta d theta. So we know that sine square theta is 1 minus cos 2 theta by 2. We take the constant Im square by pi out. Then we do the 2 also we take as constant out. Then we take the integration of 1 is theta with respect to d theta minus cos 2 theta is sine 2 theta by 2. We apply the upper limit and lower limit. So upper limit is pi. So if we apply here a sine 2 pi multiples of pi is 0, sine 0 also 0. So we are left with Im square by 2 pi into pi. So Im square by 2, which is nothing but Im by root 2. Average value to find that area under the curve for one complete cycle. Here we consider area under the curve for one complete cycle, not squared curve. Here the squared curve is taken for mean square. Since the wave is symmetrical, we are writing 1 by pi 0 to pi Im sine theta d theta. Integral of sine is minus cos. We know that cos pi is minus 1. Already negative sign is there. So plus 1 minus cos 0 is 1. Already one negative sign is there outright. So minus 1 minus 1. So minus 2, that is plus 2. So 2 Im by pi. So if you substitute in the form factor formula, it's a ratio of RMS to the average value. RMS is Im by root 2. Average is 2 Im by pi. So we get 1.11. Similarly, peak factor, if we find the ratio of peak value to the RMS value, it is Im divided by Im by root 2, which is nothing but root 2. Now we compare all the 4 parameters of considering the full wave rectified sine wave and half wave rectified sine wave. Actually, full wave rectified sine wave and sine wave both has a similar result. RMS value is Im by root 2. Average value is 2 Im by pi. Form factor is 1.11. Peak factor is root 2. Whereas for half wave, it is RMS is Im by 2, average is Im by pi, it's not twice. Form factor is more, 1.57, peak factor also is more, that is 2. So hope you understood how to find the various parameters of the sinusoidal wave.